Hello guys, welcome to the discussion of Starters 157. We will be discussing six problems from this contest. Let's start with the first one, the very basic one, glass prizes. So we have two choices, a plastic frame that costs X rupees and a metal frame that costs Y rupees. So we will buy the metal frame if and only if the price of uh, it is at most twice of the plastic frame. Otherwise, we will buy the plastic frame. So the input is just X and Y, the prices, and as per the statement, we'll just write this logic. And yes, this is it. A very simple question. The next problem is non-matching name. So Alice and Bob suggested the name SA and SB. Both are strings, right? So what they want is Alice thinks Bob's meaning sense is really bad and she will be happy if the name given is not close to SB at all. Basically, Alice will be happy if and only if algorithm doesn't share any characters with SB. And same goes with Bob that the algorithm's name should not have any characters from the string suggested by Alice. So, is there a way to name the algorithm? So basically, she gave a string of let's say A, B, C, D or something, and SB gives something like X, Y, Z, something. So what the algo name will have is like as Alice doesn't want any of the characters from street suggested by B, and Bob doesn't want any characters from this one. So basically, what the algo name can have is all characters, all characters. Basically, meaning 26. We have 26 characters, right? So and it should not contain any of the characters from SA union SB. And basically, these are all distinct ones, right? All distinct characters from both of these strings. So we'll count the number of distinct characters from both of this, and if our count is greater than or equal to 1, then we can say that yes, we can name something. If let's say if the example is ABCD and XYZ, then we can use any of like E, F, G, etc. So this is our problem. And what we'll do is we'll take a set, we'll add all the characters from the string suggested by Alice, we'll add all the characters from the Bob string, and if the set size is less than 26, meaning that we have some characters left to be used, then we can make a string from it, basically the algorithm. And yes, this is problem non-matching. And now we have another problem, not too far replacement. So here we are given an array of length n plus 1. What we can do is we can choose any index such that ai is less than twice of the last element, and we will swap them. That is, we can swap the element at index last element with any element which is less than or equal to twice of it. So what we want to do is find the minimum possible sum of the first n elements. So we are given an array an and an plus 1. We will what we want to do is we want to minimize the sum of ei from I is equals to 1 to n, and so this should be minimum. So obviously it is a sum, so we will try to push the maximum element from this starting uh, add elements to the last one. So basically, but the condition is that to swap anything, the AI should be less than, if AI is less than twice of A of n plus 1, we can swap it. Let's see the constraints. So the constraints are very less. We can use a n square logic, basically the brute force as the problem states. So we'll try to go iterate through this, and if we find any element which is greater than the element at an plus 1, and basically if ai is greater than e of n plus um, sorry, yeah, n plus 1, and if ai is less than or equal to twice of a of n plus 1, so basically we can swap. So this will, after swapping, we will have the maximum element here, and this will all contain the smaller elements. So let's see the logic. It's just a simple brute force. So and we will stop swapping like whenever we are unable to find an index satisfying this condition, we can stop our process. So I mean we keep a boolean swapped, and it's basically a while loop. So anytime we find an element greater than the last element and it is also less than twice of it, we'll just swap it. And yeah, we will continue this until uh, all of these conditions follow, and we will have the minimum number of, like, the sum will be minimum, because basically it will be the maximum element will be here. And yeah, basically a sense of sorting. Yeah, after swapping all of this, we'll just take the sum, and that will be our answer. And if we want to like uh, do it more optimally, we can sort the array, and yes, that will do in uh, like we will pass through each of the element once, but sorting takes n log n, so the overall time complexity will be n log n if we try to do it optimally. Otherwise, yet the time complexity is somewhat n square. Okay. So the next problem is small, smaller, smallest. This is a good problem. You are given a binary string, and what we can do is we need to choose some substring of s, and if it contains odd number of ones, we will delete every zero. If it contains even number of ones, delete every one. So what we will do is, let's say ones. Ones is represented by zero. So if n is even and number of ones is odd. So what was the case? If it is even, then delete every one. Delete ones and delete zeros. So you can think of like iterating through each of the substring and doing this stuff. But what ultimately matters is if you choose any substring, like if you uh, consider the whole of the substring, and if you see that we want to reduce this length, right? So if it is 0, 1, 0, 0, 1, 0. So whatever the thing is, let's say we have a count of ones as uh, and count of zeros as z. So what we see is that number of ones. Okay, let's see. In this case, now if I consider the whole of the substring, I can see that the number of ones is 2 and the number of zeros is 4. Now, according to this condition, it is odd, so we can delete all the ones. Okay, but before deleting all the ones, what we can do is, as the number of ones is 2, so we will take a substring of the given string that will contain exactly odd number of ones so that we can delete all of the zeros. So if it is 2, at some point there will be a point where the number of ones will be 1, which is an odd number. So what we'll do is we'll take that substring and we'll delete all of the zeros. And now, as we separated this part, now we'll take this part and we'll subtract all the zeros. So basically, when you divide the string, like what we'll do is we'll try to divide the string into, if it is even, then I will try to make it odd. Like even number is a summation of two odds, odd plus odd. So using this, like this cutoff, we can easily delete all of the zeros present in it. So first we will delete all of the zeros. Now we'll have two ones, right? So as the number of ones is 2, we'll delete 1. Yeah, so basically we'll remain, we'll have 1 at the last. So the answer will be 1. So what our idea is, we'll try to check the count of ones, and if the count of ones is 0, greater than 0, means we have some number of ones, and let's say the number of ones is odd, then we can, let's say the current length is n, right? So we can directly remove all of the zeros and minus z, all of the zeros will get removed. And then whatever ones we are left with, we can delete it. Like we can delete all the zeros and then we'll have some ones. So we'll, like, let's say we have some ones, number of ones as 3. So what we'll do is we can take this substring and delete all the ones. So in that case, all of the ones will get removed. And similarly for the other case. So what I'm trying to do is we'll take account of all the zeros as zeros and ones. If the number of ones is odd, I will directly subtract all of the zeros, and there is always an valid thing. And if we have ones greater than 0, that means O minus 1 will basically tell the even count, right? And in even, we can directly remove all of the ones, leaving 1. So that is why I subtracted number of ones minus 1. So this will be our answer. And if it is the other case, we can always do the same. And yes, this gives the minimum. This may be not intuitive uh, saying from the solution I explained, but if you go through the cases and you'll easily find this solution. This was the problem smallest. The next problem is normal is good. So what we want is we have the mean, the median. The median is the middle element and otherwise it's the left element. So count the number of sub-arrays of A that are normal. So normal means if the mean and median are equal and the elements only allowed are 1 and 2. Okay, so let's say we take a subarray and it has some number of ones. Number of ones is x, number of twos is y, right? So what will be the mean of this subarray? So x plus 2 into y, and the total number of elements is x plus y. This is the mean. Now the median will always be 1 or 2, right? Because they are only present in the array. So it can be 1 or 2. Try to solve with 1. If x plus 2y is equals to x plus y, this gets cancelled and y is 0. Or x plus 2y is equals to 2x plus 2y, 2y 2y cancel, x is equals to 0. So the only way we can have is either having the number of ones as 0 or the number of twos as 0. So basically, if we choose any subarray, it should have all the same elements. If it has at least one, then the subarray must have all the elements as one. And if it is two, then it should always have two. So this is the result. So we only want to keep track of the same elements in any block. And you know that let's say we have three ones. So the number of subarrays will be initially we'll have one, so we'll add our answer by one. After going here, we saw that it is same as the previous element, but now the length is greater than we can add one more, and similarly here we can add one more. Like basically it adds two more because the length is two, and here we can add three because it counts in such a way that the first case is one when considering the block size as 1. Now, if we consider the block size of 2, we can either have 1, 1 or we can have this second element 1. And now when we consider all of the 3, then it can have 1, 1, this 2 or the last one. So this is how it works. So we'll basically add at all times the block size of the current equal number of elements. So what we'll do is uh, for the first element, the block size is 1, the answer is 1. And after that, if the it is equal to the previous element, we'll increase the block size. Otherwise, if it is not, then a new block will be formed and we'll initialize the block size by 1. And every point will add, add the size of the block to the answer. And yes, this solves the problem, an easy one. Now we have another problem, unmedian. So what the question says is we are given array A of length n. We can choose any subarray such that the length is greater than 1 and all. So starting from 3, 5 and etc. Then what we can do is delete the median of the subarray. And if there are multiple occurrences, delete the leftmost. Okay. So this reduces the size by 1. Okay. So what we want to do is we want to check if the array can be sorted using any number of operations. Also, they mentioned that you do not need to minimize the number of operations. And if it is not possible, we want to output to -1. Otherwise, the ranges of the subarray. Okay. So, mhm. So let's take this case 3, 4, 1, 4, 5. So, for any element, any number of elements like e equals A1, A2, A3, A4, if you try to take any subarray of this part, like any subarray, and when you want to remove the median, it will always be the middle element, right? Middle, or if it is even the left one. So what we have is if the minimum element is because the minimum element will never come and the maximum element will never be removed uh, because when we sort it, they will be at the first and it will be at the last, and only the middle element will get deleted. So, if we see that somehow this A3 and A1 comes in opposite order in our given uh, array, then we can say that this we cannot sort this pair. Like it if it is A3 and something here, and then A1. In this case, whatever operations we do, we cannot sort this because uh, if this is the case, the median for the median, we will sort this. So after sorting, it will be something like this, and as we know that the minimum size of the subarray should be three, as I said, greater than one and all. So the minimum size can be three. So even if it consists of three elements, only this one will get deleted and this will remain unchanged. And let's say if we have multiple number of minimums and multiple number of maximums, so let's say A3, A1, A1, A3. So let's try checking what we can do. Let's say another A1. Okay, so if we take this pair, then what will happen is this A1 will get removed. So now we have A3, A1, A3, A1. Now if we try to check this one A3 will be removed. Now we have A1, A3, A1. Now another A1 will get removed. So it will be uh, uh, left one will get removed, right? So A3 and A1. So now we cannot sort this because we have reached the end and we see that the rightmost part of the minimum and the rightmost part of the maximum, if they are in the opposite order, then we can never sort them, and the answer is -1 in that case. Otherwise, if this A1 was not here, then checking any scenario will always yield us the answer because at every point we are reducing one element, and at last we'll have two elements, basically the minimum and the maximum. So if the length is n and we only want two elements at last, so we are taking n minus two steps to reach it. And what operation, what ranges we can select is any range. Let's say I'm taking 1 and 3, that every time this subarray will perform this operation. And if this case is satisfied, then this will always yield us the result because the operations don't matter and the elements uh, get removed. The elements get removed and we'll always have the sorted one at the last. So what we will try to do is we'll try to find the index of the minimum element and the index of the maximum element, the rightmost index, because the left ones will always get removed. So we'll track this, and if the minimum index is greater than the maximum index, that means that pair can never get sorted, and the answer in that case is -1. Otherwise, we'll just perform n minus 2 operations and just take any subarray. You can take any subarray here and keep on deleting. So I just took 1 and 3, and yes, this gives us the answer. Yeah, so this was about the starters 157. Uh, I I have also done normal is good problem, but the implementation part is remaining. I'll try to upload one more video for that question. And if there is any doubt regarding any of this question I discussed, please let me know in the comments. Thanks for watching.